So, hi, I'm Gerardo Cisneros. My name isn't there. I'm not allowed to put my name on corporate presentations. um, so, I'm going to give you an update on what Mellanox been doing over the almost past year. So, for those of you who haven't really heard, what Mellanox does is manufacture the glue that makes a bunch of server boxes into a supercomputer, into a high-performance computing, distributed computing system. We do the network cards, the switches, and the cables that make it possible for these systems to be at the top of the top 500. So the interconnect for the top 3 is Mellanox InfiniBand, and then 6 out of the top 10 are all interconnected by InfiniBand by Mellanox. Okay. So Mellanox had been talking about HDR for a few years, and it became real near the end of last year. The University of Michigan got the very first system. It's not a big system, so it didn't make the top 500, but they got the very first system with HDR network cards. Currently, the top academic supercomputing system at TAC, Frontera, it has HDR InfiniBand, as well as several others. Okay. It's not in here because it's not yet in the top 500 even, but there's one in Norway that I helped get on the map because they were running a variant of CESM, the Climate Earth System Model, and they had I was able to improve the performance by a factor of over 2 because by simply moving the coupler processing elements away from the atmosphere, they had them co-located, which is as bad as you can get. And they were fairly surprised that I was able to simply do that. So as I said, Mellanox designs and makes the chips that go into the network interface cards, and we call them SmartNICs because they have some computational power in them that allows us to do offloads of MPI, of various MPI functions into the NICs and the switches. There's also a system on a chip that certain customers use. That those have, in addition to the interface card chip, they have they're surrounded by ARM cores. Then the switches and the cables and the transceivers with the cables. So the glue that connects these systems together. The whole point about the smart network is offload. Let the CPUs and the GPUs take care of the real computational work and offload towards the network those functions that are mostly about moving data and processing collective operations. So the network components support are not tied to any particular processor or host. We do have this socket direct technologies that allows, for example, HDR to run over PCI Gen 3 that Martin mentioned, and we can connect them in various topologies: hypercubes, fat trees, tori, and dragonfly. Then there are offloads and remote direct memory access, a self-healing technology to work around network failures, and adaptive routing. And I'll show something about that in a minute. On top of that, we provide the software that makes it possible to use all of this stuff. HPCX includes OpenMPI with a new point-to-point, fairly new point-to-point communication library, UCX, that replaced the old MXM. We're not using that anymore. And then Sharp, which enhances the hardware collective features by offloading certain collectives into the switches and the network cards, and all of that in support of whatever applications customers have. So I'm not going to go, since these are repeated later on, I'm just going to go into Sharp. So the idea with Sharp is to offload barriers, reduce broadcasts, and more coming. And various reduction operators are supported, and both integer and floating point at different sizes of floating point are all supported by Sharp. And I'm going to show one example of a real application where Sharp provides a modest boost above the original hardware collective support that was already in the network interconnect. So if we look just at all reduce, if you do your all reduce all in software, depending on the size of your operands, your messages, the latency for the all reduce grows. But if you apply Sharp, then you get a definite performance boost. This was run on the Summit Top 1 system, and running over 512 nodes, there's a better than factor of 4 reduction in latency in all reduce. Well, I'm sorry, in barrier, both in barrier and in all reduce, even at small operand sizes. Sharp also helps AI applications. So this is the NVIDIA library without Sharp enabled, and if you enable Sharp, you get better than 10% performance improvement. And that's Sharp version 1. Sharp version 2 is coming up with HDR. Adaptive routing. This is something that's implemented at the switch level, and that chooses the least congested path from one point to another in messaging. And this, so they ran MPI graph on Summit, and without adaptive routing, the network efficiency was all over the place. But with adaptive routing, the messaging got close to 100% of efficiency use of the network. So HDR. So we had University of Michigan already had one by the time of supercomputing last year, And we had a couple live nodes with ConnectX-6 cards in them, showing essentially line rate at 200 gigabits per second. With the new ConnectX-6 cards, there's a new switch that supports 40 HDR ports, which can also be configured as 80 HDR 100 ports, which is essentially same speed as CDR. I mentioned Bluefield, which is it's both a system on a chip that contains a smart NIC, and it has these I think 8 ARM cores, and the transceivers and cables that support all of that, and HPCX, the software to take advantage of it all. Many people aren't aware that this is what gets you the performance out of the InfiniBand network, the Mellanox InfiniBand network. I'm not going to go into the hardware details. The presentation is going to be made available. The switches can be racked into really humongous systems. And now for the real stuff. So a colleague of mine, Yong Chin, was tasked to work on ICON for the German Climate Computer Center. And so they were running ICON for production using OpenMPI 2.0 and an old version of HPCX, really old, 1.0. And they couldn't go to a more recent version of MPI because the model for composite data structures in MPI was broken. So together with a professor and his student at UTK, but the developers at German Climate Center and Yong, or I should say Dr. Chin, they were able to allow, so a new data exchange module was developed, put into HPCX 2.4. And so with the new point-to-point communications library and hardware collective library, a definite performance improvement was achieved for ICON. Next, I was given access to the UK Met Office's software. And so I had several benchmark tests that I was allowed to run. I'm not allowed to put on any real numbers on the vertical scale. But the point is to show that there is some modest improvement just by enabling hardware tag matching for the point-to-point communications for this particular model, which is the running in the climate mode. And then the next one was NEMO, also provided by UK Met. And for that, HCOL, enabling the hardware collective support offloads to the network, provides also performance improvement. And the final slide is also UK Met's VAR. And the difference between just using the hardware collective library and enhancing it with Sharp gives a modest improvement in performance as well. And that is, we promised that we were going to show the roadmap. This is the InfiniBand Trade Association official roadmap. So HDR came online at the end of 2018, And if all goes well, the next generation, which should double the bandwidth, this is my last slide, actually, should be become available sometime next year. And then whatever's in the future, it hasn't been decided when and where. And that was it. Thank you. And before I finish, does anyone want to venture what the answer to Eileen's two questions were? Yes, Stan Posey is not allowed to participate. Yes? Networking technology.